Hi students, what if we are working in MATLAB or Octave and we want to create a function to solve a task for us, but that function needs more than one input and generates more than one output. So let me show you how to handle multiple inputs and outputs in MATLAB and Octave. So the first thing I'm going to do is I'm going to open up a new script file, and this is where I'm going to do my function definition. So if you remember from the last video, that the first line of your function actually needs to have the keyword function, and then after that we're going to put in an array of outputs. So it's the outputs that go first. So this is just a list of the things I'm going to output. So my function is going to be a series circuit solver. So I'd like to report to the user what our equivalent is, and current, and the power. So those are all of my outputs. They're enclosed in square brackets like that. And then the next thing for the format is I have equals, and now goes the name of my function. So I'm going to call it solve series circuit. And now goes my inputs. So I open up this time not a square bracket but a parenthesis. And now in order to, I'm just going to do a simple series circuit with two resistors. So I'll have R1, I'll have R2, and then I'll have my voltage source V sub S. So there is the first line of my function. Just so I don't forget, I'm going to go up here to File, and I'm going to save this file as the exact same name, case sensitive, of the name of my function. And MATLAB and Octave is pretty smart. Sometimes this is going to auto-populate for you so that you don't have to type it in and make any spelling mistake or case sensitive mistake. Otherwise it won't be able to find your function. Okay, great. So now I have the first line of my function definition. Now when I hit return, it's automatically going to make my end function. So this is going to enclose the code block for my function definition. And now I want to assign these outputs to the calculation that involves my input, and then that's output's going to be reported to the user out in my main function. So the first thing I want to do is I'm going to compute R equivalent. That's my first output that I have listed in my list of outputs. And for a simple series circuit that just has inputs R1, R, and R2, R equivalent is just defined as the sum of those. So that's going to be R1 plus R2, and that's it. And then the next is I need current. So for current, I'm going to do an Ohm's law calculation. Ohm's law is V equals IR. So to solve for current, that would be I equals V over R. So I'm going to take my Vs, that's my source voltage, I'm going to divide by the R equivalent that I just found. And then finally, to find power, I take current and I multiply it by voltage. So that's going to be current times Vs is the name of my voltage variable. So now I will control S that, so that's saved, my function here. I better put a comment in here to remind myself what this function is. So I'm going to start a comment with the percent sign, and the name of this is solve series circuit function. Takes in as input R1, R2, and R and Vs, and computes the equivalent resistance, the current generated by the source, and the power supplied by the source. Okay. So I don't have wraparound comments on, so I'll put another comment there. And it's a good idea too if you want to have the date of your revisions. So this is 3/6/2021, and then I could put my name, and I'm going to save this. And now I have my function defined here. Now I'm going to call my function from my main script here. This is where I define my variables, I call functions, and I do any communication with the user. But just to make sure that I don't need to debug this at all, I'm going to run this in the command window. So just to start off, let me try this with some easy values so I know the answer, just as like a proof of concept. So what if I made R1 10? We'll make R2 equal to 20. And then suppose our source voltage we're going to connect this to is a 9-volt source. So now I've got all my input variables defined, and I'm going to, and I can call these anything. They don't actually have to match the cases of the way I have these variables declared up here. I can call it, resistor 1. I could call it resistor 1 with a little r or a big R. The wording doesn't have to exactly match my definition up here that I made in my function. So once I've defined something that I can use for my input, now here's what we have to do when we actually run this function. So keep in mind this function is going to spit out 3 outputs. So we need to have enough variables to catch those outputs when they are produced by our function. So what I'm going to do is I'm going to make an array. So this is going to be my list of variables. And the first one is going to be our resistance equivalent. I'll call it that so it looks different than my function definition. You can call it the same thing if you want to, but I usually try to call it something different just out of habit. And then we'll have the current, and then we'll have the power, something like this. So those are the variables that will exist in my main function, kind of my command window, that are going to catch the output variables, our equivalent, current, and power that are generated by my function. So I'm going to set this equal to the name of my function, solve series circuit. I can just do a tab complete. And then I'm going to pass in the variables that I just defined above. So R1, R2, and Vs. And when I do that, if I don't put the semicolon at the end, I see that res EQ gets filled with 30, which is 10 plus 20. The current gets filled with 9 divided by 30, so 0.3. And then power gets populated with the current times the voltage. So I didn't run into any syntax or runtime errors just doing this first test. So I'm going to assume that code's pretty good. It operates the way I expect it to. And now what I can do is I usually just kind of copy and paste this stuff into my main function because I know that this code is working. So in main, if you want to take this that you wrote, copy it in here, and of course you have to get rid of these. So I have R1, R2, Vs defined, and then I run my function, solve series circuit. I put my inputs in here in the parentheses, and then I catch the outputs here in square brackets. I know that I designed this function to produce 3 outputs, so I grab those 3 and I store them in these variables here. Now I can save my main function, and if I don't put this here, then when I come down, I can test this with a different value, say. So suppose here I want to test this with 15 and 25, and instead here I want to put a 10-volt source. Then I can save that, and then I can run my main function. And this is going to give me new values, which I can use my calculator to check and make sure that that's what I expect. And now I have my code organized in the main function, which does my, I can change my variables from here, and then I pass them into my function, which exists in a different .m file. And it's a good idea to organize your code like this. If you are hard coding values like this is, not stylistically not the best thing to do, but as far as like first learning how to define functions, this is keeps it nice and easy. But we wouldn't want to actually hard code values in our function here, because then we wouldn't be able to use it generically for any circuit that we might be given. So if we do it in the main function, then we only have to change these values here for the different problems that we might get in the textbook. And then we get to call this function every time we need to solve a series circuit. And it's written generically. We have no hard-coded values here, and it produces all of the information that we would need about a series circuit. So there's an example of how to define a multi-input and output function and how to call and run it within another script. So let me know if you have any questions.